Hey George, didn't sleep yet. What happened?
No, Mom, I have a test tomorrow. I just remembered now. What shall I do now? It's already too late. Only a little time left. Oh no. I would be failing the test. What will I do now, Mom? I am ashamed in front of the whole class.
Hey George, just wait. Why are you crying for a simple test? You should be so brave to face it. It's okay, I can teach you in the most simpler way. Just stay calm. Just tell me, what is the subject?
The subject is the computer. And the content is about the linked list operations.
Wow. Thought so cool. Why are you worrying about this? I work in IT field, right? So I can teach you this simply, my son.
Yes, Mom, you're right. I'm ready to learn it. Please start teaching. Quicker, please.
Okay. A linked list is a sequence of data structures, which are connected together via links. There are some basic operations supported by a list. Insertion adds an element at the beginning of the list. Deletion deletes an element at the beginning of the list. Display displays the complete list. Search searches an element using the given key. Traversal access each element of the linked list. Search find a node in the linked list. Sort the nodes of the linked list. Merging to merge two linked lists into one. Linked list traversal. The idea here is to step through the list from beginning to end. For example, we may want to print the list or search for a specific node in the list. The algorithm for traversing the list starts with the head of the list. Access the content of the head node if it is not null. Then go to the next node if exists and access the node information. Continue until no more nodes, that is, you have reached the null node. Next, linked list node insertion. There can be three cases that will occur when we are inserting a node in a linked list. Insertion at the beginning, insertion at the end. Insertion after a given node. Insertion at the beginning, since there is no need to find the end of the list. If the list is empty, we make the new node as the head of the list. Otherwise, we have to connect the new node to the current head of the list and make the new node the head of the list. Could you understand the insertion and traversal?
Yes, Mom, I can understand this better than my professor.
Good. The next one is the insertion at end. We will traverse the list until we find the last node. Then we insert the new node to the end of the list. Note that we have to consider special cases such as list being empty. In case of a list being empty, we will return the updated head of the linked list because in this case, the inserted node is the first as well as the last node of the linked list. Insertion after a given node. We are given the reference to a node, and the new node is inserted after the given node. Deletion. To delete a node from a linked list, we need to do these steps. Find the previous node of the node to be deleted. Change the next pointer of the previous node. Free the memory of the deleted node. In the deletion, there is a special case in which the first node is deleted. In this, we need to update the head of the linked list. The last one is the linked list node searching. To search any value in the linked list, we can traverse the linked list and compares the value present in the node. So these are the main operations we make in linked lists. Keep these operations on your mind and just revise your book by tomorrow morning. I'm sure you will got this and pass the test with great scores.
Thank you so much, Mom. Now I feel a little relaxed. I hope to score good marks in the test. I feel so sleepy, Mom. Let's go sleep. See you on morning. Good night, Mommy. Love you.
Good night, son. Love you too.